All right, so now what we're going to do is we're going to start transforming our logarithmic functions. So things we've been doing all semester: horizontal shifts, vertical shifts, stretches and compressions, reflections. And so this is just kind of the overview to kind of see what it looks like. And then we'll go into more detail on each one of these in a little bit. So horizontal shifts. Okay, so we're going to have our log base b of x, and what do we get with horizontal shifts? Where is that going to be put in? Well, it's going to be put in with our x. So we're going to have some constant c is going to be added to the input of the parent function, and this shifts will be to the right if c is less than 0. So we're going to have x minus c, and it's going to be to the left if c is greater than 0. So if we have x plus c. Okay, so if we have a c of plus c here, we know we're going to move left, and if we see a negative c, we're going to go to the right. And so that's how that's going to work. Vertical shifts, well, we're going to do like we've been doing before. We're going to add or subtract d to the whole function. So d is added to the parent function, and that results in the shift corresponding to the value of d. If it's a positive, we move up, and if it's negative, we move down. Okay, and again, that's kind of what this shows here. Now, what about stretches and compressions? Well, what's going to happen is we're going to multiply our log base b times some a. Now, if this one is going to happen is if a is greater than 1. Now, all of them are going to be for a constant a greater than 0. And this one's going to give us for a greater than 1. And this one basically, we could think of this as really just an a. But here what happens is your a is going to be basically between 1, oops, not 0, less than or equal to, and 0. Okay, and so that's how we're going to get that fraction, and it's we're writing as 1 over a, but that's to make it so that we have this greater than 0. But what happens is this a is going to be, a fraction when it's going to be in this form here. Okay, so it's really going to be something between 0 and 1 when we have this one. And then we have reflections of f of x. Okay, so if we have a negative here, that's basically going to change all the y values. And so that means it's going to reflect across the x-axis. So if we had a up here and we change the sign to negative, well, then all of a sudden we're now down here, and that's we're going across that x-axis. And so our domain is still going to be 0 to infinity. Our range is going to be negative infinity to infinity, and our vertical asymptote is still x equals 0. Now, what happens though is if we have inside here, if we make a negative x for our input, that's going to reflect it across the y-axis. And so now what happens is if we have x here originally, then if we put in negative x, that puts it over here. And so then we have something over here. And so we've reflected it across that y-axis. So that's going to be the key thing. And does that change anything? Well, yeah. Now our domain is going to go from negative infinity up to 0. Our range stays the same and our asymptote stays the same. It's just now we're going from this asymptote going to the left. Or maybe we were going to the left to start with, and now we're going to go to the right. So it all depends on where we started and where we finish. All right, so let's look at that horizontal shift. Okay, so we have that log function. And so we're going to have some constant c. So we don't know what that c is. And the function is going to be log base b of x plus c. So if the c is greater than 0, we're going to shift the function left. Okay, so if that's greater than 0, that means we're going to shift left. And so what happens is we're going to start with our base function, and that's kind of the key thing. We're going to draw a base function in easily because we know our points 1, 0, and b1. And then if we're shifting left, we're going to shift left by c units. And so this point over here becomes b minus c, and this one becomes 1 minus c. And that's the only change is our x's change. And so, become 1 minus c now, and so we put a dot there. And this is b minus c, we put a dot there. And our new asymptote is at x equals a negative c. Now, what if c is less than 0, so we get x minus c or something like that? Well, that means we're going to shift to the right, and so our c is going to be up here. It's going to be positive, and we're going to add c to this, so 1 plus c. We're going to add c to the b, we're going to get b plus c, and this is what the function looks like there, whereas this one is what the function looked like there. Okay, so that's how we do this one. Now, our vertical asymptote becomes, negative c, the opposite of c. So if this was a plus 4, well, it now becomes the vertical asymptote's at a negative 4. Now, if this was minus 4 here, the opposite of that is plus 4, and so that's why it's over here. So that is going to be the key. X is going to be the opposite of whatever c was, and our domain then is going to be from the opposite of c to infinity. So it's going to be from here, negative c to positive infinity. Here it's going to be from c to positive infinity. Now our range doesn't change. It's still from positive to negative infinity there. All right, so what if we want to graph this? All right, well, first of all, we have to think of what is our asymptote now. All right, well, if we set that x plus 4 greater than 0, subtract 4, x has to be greater than negative 4, and so that's where our asymptote is. So 1, 2, 3, 4, x equals a negative 4 is our asymptote, okay? Now, we also know what our original points are, because what is our base function here? Our base function is log base 3 of x. And so our base is 3, and so that gives us original points of 1 comma 0 and 3 comma 1, because remember, that's always going to be there for just our base function, and this is going to be b comma 1. B is 3, and so if we plug those in, 1 0 and 1 2 3 1, this was going to be our original graph. So we would come up here and we'd have something like that. So that's our parent function, okay? So they say that we have to graph our parent function, and then we have to graph the other one. Well, the other one, remember, is we have a plus 4 here, so we're going to move to the left 4 units. So we're going to move left 4, 1, 2, 3, 4. We move that one left 4, 1, 2, 3, 4. And so here, it would give us something like that. Again, my drawing leaves a lot to be desired, and this was our original x equals 0 asymptote, okay? Now, include key points and asymptotes on a graph. So that was the first asymptote original. Then we moved it to this as a new one, and our domain and range. And now all we're going to worry about is the domain and range of our new function. So the domain and our range. Well, the range, you know what? It doesn't change. It's still going to be from negative infinity to positive infinity. But our domain now, we scooted that over to negative 4. So that's a negative 4, and then it goes to positive infinity. And so this is really what we're looking at for our new graph, and this is our old one. Okay, and an old one, we already know what the domain and range and asymptote are, so we don't worry about that one. But for the new one, that's what we have here. Okay, again, we started with our original points, and then we just moved left 4. So, we moved left 4, so that becomes a negative 3, 1, 0. Move left 4 here, that becomes a negative 1, 1. And that fits what we should see. All right, so let's go. Oh, now let's pause here and let's go take a break and we'll come back.